Hi, my name is Andrea Clary. I'm a field applications engineer for the Keithley products. And today I want to talk about how we can use a dual channel SourceMeter product to perform a DC current gain or hFE test on a bipolar junction transistor. hFE, we're going to typically use this one to apply some sort of a voltage bias on the collector, and we're going to measure the current, the collector current, and then whilst this channel would, in this case for hFE, is going to apply a current into the base, and then from the ratio of the collector to the base current, we know what the gain is. Now, transistor data sheets are going to call out some test conditions for that. In this case, it's saying we want 1 volt on the collector, and then we want to adjust that base current until we achieve 10 milliamps, and the ratio of that 10 milliamps to the required base current should result in a gain that's somewhere between 100 and 300. Now, using those values of gain and this relationship, we can estimate how much base current we're actually going to be required to inject. So somewhere 33 or as much as 100 microamps is going to be required to cause 10 milliamps of current to flow when this guy's applying a 1 volt bias to the collector. So anyhow, let's take a look. So first pass on this, let's just do a manual operation on this. And I'm going to switch the view here to an internal web page virtual front panel of the source button here. So let's first set that collector voltage to 1 volt. So I'm going to uprange again, and then I'm going to switch over and actually interact with the instrument, and I'm going to hit enter there. Now this measure button, similar to the display button, is just going to cause a carousel, but in this case of just the SMU B, what is displayed to be measured. So if I hit that, it's going to come to display ohms, watts, and then amps. And if I hit it again, it comes back to volts. Okay, now this one, so we could turn that on. We're applying our 1 volt, and no current's going because the base is being held off right now. Okay, so this one, we don't want to source voltage, we want to source current. So if I hit the source button and then hit it one more time, and then you see it toggles to, so right now it just would toggle back and forth between being a voltage source. We want it to be a current source. I'm going to uprange my sourcing range here. Right, we're going to need as much as 100 microamps, so I'm going to go ahead and use that range. Okay, let's test this. So I'll turn on that one, and I'm going to turn on this one. Okay, and I'm going to start adjusting there. So there's 10 microamps into the base, and we're getting 2.54 milliamps of collector current on channel B. I'm going to increase the base current, get more. Go again, 30 microamps, 7.2, 40 microamps. Okay, that's really close. So I'm going to go down to the next digit, 41 microamps, 42. Now we're a little over, so we'll come back to there. Okay, so we would note down these two numbers and compute our gain like it did here. So so it's basically it's an inspect part, and you've been able to perform this test just with a simple source meter, manually operating it. Now, as a kind of a continuation of the topic, rather than run the test completely manually, because maybe that feels like it's going to take too much time. You don't want to do some arithmetic on the side, or or even what if it's a power device where the data sheet there calls out that you need to do this under pulse mode, right? This manual operation I've shown up till now, not gonna be consistent with that. So what you can do instead, if you still want kind of a simple, benchtop tool without a computer tied to it, is you can run a collection of commands as a script on these instruments. And here I've shown some screenshots where I used a pulse mode script on, it was actually this component, 4 volts, 4 amps. So we tested it at near to 4 amps in spec, and then I'm able to, with the script, it prompts for an input parameter. You know, if I want it to, it's how I wrote the script that it will do that. And so I'm able to, instead of taking the default of 4 amps, I was able to provide an alternate value, and then that same exact, you know, saved script will carry out the test at that different condition. So let me show you what that looks like. Not a pulse mode this time because I'm wired out still to that little 2N 3904. But so under menu, there's script, and we'll do enter, and we want to load, and it's on the USB drive. So a script that I wrote to so anyhow I brought it to the instrument on the thumb drive, and I've got a DC one, and then I've got a pulse mode one. But let's come back to the DC one for this, and then I'm going to do enter, and it says that it's been loaded as an anonymous script there, and then I do want to make it active for run. Okay, so it's now the active script in the runtime memory of this instrument. Okay, so when I press run, it's going to run, and it's prompting me for the current. It's defaulting it to 10 milliamps because that's how I wrote it. So I'll just do that, and boom, there it did the test. I can run it again. Only this time, let's set the current to 22. Now hit enter, and there it is. So I hope you find that useful to get some insight into how these instruments can become kind of purpose-built tools just by running some scripts. Okay, thanks. Bye-bye.